Hi everyone, this is Math 6, Lesson 7-5, represent solid figures using nets. In this lesson, we'll be able to represent solid figures using nets. Let's look at Explore It. Jamal is breaking down items for recycling and wonders what this box will look like when it is unfolded and flat. Have you ever folded a box from a net paper? A net plan is where you have a flat paper and you fold it using the lines on the paper, you get a box. So Jamal is wondering, if you tear this box and then if you cut this box and then make it flat, what's it gonna look like? All right, part A, how did the size of the box help you think about what the unfolded box will look like? So we have 16 inches, this is the longest side, 12 inches height, that's the second longest, and then 4 inches wide on the bottom. So you know there's gonna be a base. You know there's gonna be a rectangle on the bottom that has a 16 inches side and 4 inches side. What about the side that's on the sides, right? So the dog eats biscuits, the front cover side would have 12 inches long and 16 inches on the bottom, but you gotta lay it flat. And then what about this side? You can have 4 inches by 12 inches, and same here, 4 inches by 12 inches. And then the one on the back, you can't really see, but you know it's gonna have 12 inches by 16 inches, right? These are all 16. And then what else are we missing? We got all the 4 sides and the base. We're missing the top one. The top one could go anywhere, but what if we put it over here? It's gonna have 16 inches by 4 inches. So it's the same as the base. So that's gonna be the flat version. So we can say, you know that the unfolded box will have 6 rectangles and you know the dimensions of the rectangles. Let's write that down. We know that the unfolded box will have 6 rectangles and we know the dimensions. So part B, how can you use the grid to represent the unfolded box? Let's put this on the grid, okay? 1 grid is equal to 1 square inch, 1 square. So we're gonna count 12 inches, 16 inches over here. So we're gonna rotate this figure and then put it on the graph like that, okay? I'm gonna rotate it like this. And then we're gonna have something like that, okay? So let's start with the base, 16 by 4. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 by 4 inches. 1, 2, wait. 1, 2, 3, 4. Okay, that's 4 inches. And then 4 inches here. Okay, that's the base. It's actually very, very steep rectangle. And then we have this part where it's 16 by 12 inches tall. So that's still going to be 16, but we're going to count 12 from here. Okay. So one, you can't really see. Let me zoom in. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That's going to be 12 inches. And I count the same 16 inches over here. And this is the 12 inches by height. Okay. And then what do we have? We have the top that's 16 by 4 that's connected, right? So you can do another 4 inches. Wait, I only counted 3 over here. That's not right. Let me put in another. Okay. And then 4 over here. Sorry, my lines are not straight. But you get the idea, right? And then what else do we have? Now we can connect this top part with the other side. Or from here, we have 4 by 12 inches. So we have to go this way, but we don't want to. So why don't we say this, well, let's attach it to this side, the dog freeze biscuit part. And we can say, oh, I can draw 4 inches by 12 inches over here because they're connected. Okay, this is the side. 4 inches by 12 inches over here, and then 4 inches by 12 inches over here. And then what are we missing? We're missing the behind, right? The behind part. Another 12 by 16 inches. So let's put it over here since it's connected to the top. So we're going to count another 12. 2, 4, 6, 8, 10, 12. There we go. Okay, that should be 6 rectangles. 1, 2, 3, 4, 5, 6. That should be the accurate unfolded box on the grid line. There we go. And now let's look at focus on math practices. Is there another way to represent the unfolded box on the grid? Explain. Yeah, we already put another way here. You can attach the full 4 sides on the base and attach the top base with one of this bigger rectangle. So as long as they're attached correctly and they have 6 sides attached correctly, then yes, there are many ways actually. There are many possible nets for the box. So these are called nets. Okay. So in this lesson, we will think about how we can classify and represent solid figures. Let's look at example 1, classify solids. How can you classify a polyhedron? Vocabulary word. So what is a polyhedron? Polyhedron is a 3-dimensional solid figure made of flat polygon-shaped surfaces called faces. Okay, these are faces. The line segment where 2 faces intersect is called an edge. The point where several edges meet is called a vertex. The top and bottom of a prism is called bases. So these are bases, top and bottom. Base is like, faces are the sides on the side. Okay, that's one face, two face, another face on the back, and there's a side face over here. Okay, it's a face. It's like facing the side. And then your edge is this line. Vertex is this point. Okay. So remember those vocabularies. Look at prism. What is a prism? This is a rectangular prism. That's a triangular prism. What do you notice about prism? What could prism be? Prisms have polygonal faces. That means their faces, their sides are going to be polygons. Okay, polygons have two identical parallel polygon shaped bases. Okay, they also have polygon shaped bases, but they're the same shape. The bases have to be the same shape. Look at triangular prism. The sides are rectangular, but the bases are triangular. So it's called the triangular prism based on the basis shape. Okay, but yeah, they're also parallel. The faces have to be identical, which means the same. Prisms are named by the shape of their bases. Okay, that rectangular prism comes from the base, rectangular base. What about this one? What's this called? So you might say circular prism, but it has its own name. It's called cylinder. Cylinder, which is really circular prism, but nobody uses that word. Okay. Yeah, because it doesn't have any faces. It does have one face. It's rectangular face, but it's not like, you know, it doesn't have edges. So pyramids, look at the pyramids. The base of a pyramid is a face opposite the vertex where the triangular faces meet. Pyramids have a vertex on top. It only has one base. This is a square pyramid looking at the base, and that's a triangular pyramid. Okay? So think about the difference between the prism and the pyramids. So let's look at this triad question. Classify the solid figure. What is this called? Just classify it. What's the name of this figure? It is, what's the base? It is a square and it has a vertex. So it's a pyramid, square pyramid. All right, convince me. What attributes of a solid figure should you identify to classify it as a polyhedron? What's a polyhedron again? They must be, these are all types of polyhedrons. What's a polyhedron then? It must be 3D, three-dimensional, and have all flat surfaces with polygon shapes. Okay, so does that mean a cylinder is also a polyhedron? No, this is not a polyhedron. Okay. Let's look at example 2. Identify a solid figure from a net. Looking at the net, like we looked at in example, the first explore it, right? What solid is represented by the net? This is the back, front, that's top and bottom. So we got two bases that are identical. And then we got 4 faces. The net is a plane figure pattern. It's a plane figure pattern, 2D pattern, which when folded makes a solid. The net shows 3 pairs of identical rectangular faces. So if you fold it, it's going to look like this. It's a rectangular prism because the base is rectangle. And the top and bottom, you have two bases. So it's going to be a rectangular prism. Example 3, draw a net of a solid figure. How can you draw a net of a rectangular prism that has height of 2 units and bases that are 4 units long and 2 units wide? So step 1, draw the base. Step 2, draw the sides, draw the faces that are attached to it, to the different sides, different edges. And then step 3, the last step, you draw the top base attached to one of the faces. Okay, so try this question. Identify the solid from its net. What kind of solid would this be? The shape, what is the shape of polygonal faces? What is the shape of the base? This is a net of a blank. Can you figure this out? So looking at the net, the shape of polygonal faces, like the faces, you have 3 faces. They are triangle, right? What about the base? The base is also a triangle. So this is a net of a triangular pyramid. Yeah. So that was our lesson 5, representing solid figures using nets. Let's summarize our lesson. You can use nets to represent solid figures. This is a net, and then you fold it to make a solid figure. This is a net, you fold it to make a solid figure. Pyramid and prism. Pyramid has 1 base and a vertex on top. Prism has 2 bases that are identical and they're parallel to each other. All right, guys, that was lesson 5, represent solid figures using nets. We'll continue with lesson 6, finding surface areas of prisms, in the next video. If you have any more questions, please ask Ms. King in class. Bye.